Okay, good morning everyone. Today we're going to work with exponents, combining them and what happens when I'm multiplying exponents or taking the power of exponents, taking the exponent of an exponent, you could say. Okay, so here we go. Our basic idea, what are exponents in general? Okay, what are exponents? What are exponents? So exponents, oh, come on, pen. Yep. So exponents. So what are exponents? Exponents are a fast way for me to write out multiplication. If I say 3 squared, well, this is simply just 3 times 3, or 9. And it's something that we've seen before. We've seen squared pretty often already, and by the time we're freshmen. If I say 3 cubed, this exponent says, hey, I'm going to multiply our base number 3 times 3 times 3 times 3. And that's going to be 27. So the parts of an exponent, we call them powers, exponents. So this is what we call a power. So this will, the main thing we want to worry about, that's called the base. That's the number that we're repeating. The base is the number that we're constantly repeating. If I say 3 to the 4th power, right? Power is this exponent part. It's 3 times 3 times 3 times 3, which is really 9 times 9, which is 81. Now on your calculator, if you guys have a calculator on hand, you could practice this by using a couple of key, a couple of buttons. The most typical one, when you see in a scientific calculator, you see one that has this little symbol. It could be A, B, or you might see X, Y. And the way we use it is we say 3xy or 3ab4, and that should give you 81. It equals and it should give you 81. Or you do 3xy, that should also give you 81. Some of you guys have nicer calculators where they don't write this xy, they write a caret instead. I mean, they use a little arrow to denote a superscript. So you might have something like 3, and then your symbol is going to be a little caret like that, 4. And this really means 3 to the, bump it up, 4th power. So if you guys do have a calculator, you guys can try that and see. These are notations that we've seen before. Now, is it supposed to be hard? No, it's supposed to be a lesson on right now how to read these. Now, what if I ask you 3 to what exponent is equal to 81? Okay, 3 to what? How many times would I need to multiply 3 together to end up with 81? And as you can probably see here, that's going to be 4. So x is equal to 4. And now in Algebra 2, we'll find ways of solving this using your calculator and algebraically. But right now, it's just, hey, how many do we need? If I ask you 10 to what exponent is 100? Now, tens are a special case because the number of zeros you have are the number of tens we used. So in 100, isn't that simply 10 times 10? So we have 10 squared is 100. So x is equal to 2. But let me give you along that same logic. What if I wrote 10 to what power is 10,000? And the hint here again is counting the zeros. So count how many zeros we have. That's how many tens we use to multiply to get up there. 10 to the 4th power is 10,000. That's 1, 2, 3, 4. Okay, and there's a little hint there. If I have a million, how many tens are in a million? There are 6 zeros. So that's 10 to the 6th power is 1 million. Oops, lost a 0. Okay, so x here would have been 4, and x here would have been 6. So that's a special thing about integers. Okay. What about, so numbers are easy. They seem pretty fairly easy when it comes to exponents. What about fractions? Oh my goodness, what about fractions? What if I write 1 over 2 and I decide to square it? Well, this doesn't change. What if I write out the fraction separately? What if I say 1 over 2 times 1 over 2. So fractions, here is our special rule if you don't remember about multiplying fractions. We always multiply top to top and bottom to bottom. So whenever you're multiplying fractions, it's always top to top and bottom to bottom. So that's 1 times 1 is 1, and 2 times 2 is 4. Now I'm going to give you a different way of looking at this, slightly different. 1 times 1 and 2 times 2. This could also be written as 1 squared over 2 squared, which is our same answer, 1 over 4. Okay. Let's do the same problem, except let's change the numbers a little bit. Let's say 2 over 3 to the third power. Now, the exponent says how many times we're going to multiply this. So in this case, the exponent is a 3 to the third power. And that means we're going to write this 1, 2, 3 times. 2 over 3, 2 over 3, 2 over 3. Now you might be wondering why I wrote a parentheses here. Couldn't we just, like our x squared and everything, just leave it? If I write 2 over 3 cubed, who do you think the cube goes for? The 2, the 3, or both of them? If you look at the way I'm writing this, this is actually looks like it's only 2 the 2. So this is really 2 cubed over 2. So over 3. So we have to be careful, and when I write the parentheses, I mean everyone in that fraction is getting cubed. Now we can write this as 2 times 2 times 2 is 8, and 3 times 3 times 3 is 27. Or writing here 2 cubed over 3 cubed. That's another way for us to look at this. Now on your homework, they're going to give you problems that are in decimals. So let's change decimal numbers and say 0.6 squared. 0.6 squared. Now, in our classic way in 8th grade and 7th grade math, we were taught to multiply decimals. So I'll do this on the side, decimals. And we were taught to write 0.6 and then 0.6 and to multiply those across. If you guys remember, this is our classic way of doing it. So we say 6 times 6 is 36. And then we copy how many decimal spaces we moved. We move 1, 2, so 2 decimal spaces. So we move it 1, 2 decimal spaces, 0.36. Okay, that's our classic way of doing decimals. But I want to change this up slightly so you guys can see this in a different way in fractions. Now, what is 0.6 in a fraction? 0.6 is another way of saying a tenth, right? That's a tenth. Tenth. So that's 6/10. So this can be rewritten as 6 out of 10. And this is our fraction way of writing this simple decimal. It's just you move it over by the number of decimal spaces by dividing it by 10. Okay, so for this problem now, what's 6 times 6? That's 36. 10 times 10 is 100. Right? If you want, you can write this as 6 over 10, 6 over 10. And of course, our reason why we're writing exponents, so we don't want to have to write that repeatedly. So 6 times 6 is 36, and 10 times 10 is 100. Now, moving this over, this is 36 with 2 decimal places if you really wanted to. Let's do one more example of this. Let's do 0.03 to the cube power. So let's rewrite this fraction. That's 3 pennies, right? Can you think of that as 3 cents? So that's 3 out of 100 cubed. So what is this going to be? On top, 3 times 3 is 27, times 3 again is 27. 3 times 3 times 3 is 27. Over 100, I'm gonna write this as, now here's the thing to consider. 100 cubed means I'm gonna have 100 once, 100 twice, 100 3 times, or you can say I have 1 set, 2 set, 3 sets of zeros. See, 1 set, 2 set, 3 sets of zeros. Now this is a pretty long number. Now if I write 27 here, start the decimal in the back, we need to move it 1, 2, 3, 4, 5, 6 spaces. 1, 2, 3, 4, 5, 6 spaces, and fill in all the spaces in front of it with a 0. Could we have done that an old-fashioned way? Sure. 0.303 times 0.03 times 0.03. Now, if I multiply these together, that would be, on our old classic way, we would write 0.03 times 0.03. And that seems like a lot of work. 9 with 4 spaces. 1, 2, 3, 4. And then we would do 0.0009 times 0.03. That'd be 27 with 1, 2, 3, 4, 5, 6, 7. Now you tell me which way is faster. These are both exactly the same answer in the end. But I find like maybe this might be slightly a little faster. Maybe, ish, you know, ish. Okay, let's do it one more time with a bigger number or more exponents. More power. So 0.4 to the 4th power. Practicing this, writing a different way. This is 4 over what? 4 over 100, 4 over 10. Okay, think about it. 4 over 100, 4 over 10. That's a 40 cents. So that's 4 over 10. Now we can multiply 4 times 4 is 16, times 4 is 64, times 4 again is 256. That's just because I multiply up to 256 a lot. And then divided by, okay, here's a trick. 10 to the 4th power is just 1, 2, 3, 4. 1, 2, 3, 4. That's a trick about multiplying to the exponent. 10 to the exponent. That's just the number of zeros. 1, 2, 3, 4. To rewrite this, we write 256. Starting from 0, we count how many zeros on the bottom. 1, 2, 3, 4. We're going to move 4 spaces. 1, 2, 3, 4 spaces. So 0.0256. Okay. So these are a couple of skills that we talked about with exponents already. Now, one is rewriting exponents. The first thing is just understand what exponents are. Second was, what about fractions? Do fractions work the same way? And they do. If I tell you I have 3 of them, we go on to write this 1, 2, 3 times, multiplying the top by the top and the bottom by bottom. Well, if we have a decimal number, we can convert that to a fraction and work it as a fraction. And then the last part here is we're going to learn how to multiply powers. So today, this is the main part, product of powers. How do we multiply exponents? How do we multiply exponents to make this easier on us? And there's a rule for everything, right? There's a rule of math for everything. And this rule is going to be very easy, but the problem is you might confuse it with another rule, and we'll talk about both those rules right now. But we'll only be practicing one of them. We'll practice the other one later. So this rule is called product of powers. The word product means multiply. Oh, darn it, come on. Multiply exponents. Okay, the fancy idea here is multiplying exponents. So what if I tell you 3 squared times 3 cubed? We have 3 to the what on top now? What would this be? 3 squared times 3 cubed would be 3 to the what? Well, isn't exponents just multiplying anyways? Isn't this really 3 times 3? And over here, isn't this 3 times 3 times 3? All right. Well, weren't we trying to multiply these two together? So there's another multiply here. So you can see this is actually all multiply. How many 3's do we have in the end? 1, 2, 3, 4, 5. We have 5 threes. When you're multiplying powers, the main concern that you have is that you're multiplying the same base. It's like oranges, right? If you have a pile of oranges and apples, you want to make sure all the oranges are together and all the apples are together. Make sure it's nice and neat. Some of you guys might get a job at Walmart or at Avon's, and you'll be doing groceries. You're stacking the shelves. Make sure everything is where it's supposed to. Now, why can we do this? We can't do it for this. If I say 2 cubed times 3 squared, these do not have the same bases. And oftentimes kids will make a very bad mistake and they'll say, oh, Mr. Look, this is 6 to the 6th power. Because they'll just multiply everything together. And that is completely, sadly wrong. If I say 2 cubed, this is really 2 times 2 times 2. How is that related to 3 times 3? It's not, right? There's not enough pairs to make 6. So while you're saying this is 6 times 6, 6 to the 6th power, that is wrong. Whoops, I'm not sure why I wrote x there. I think I was supposed to say not equals, and then I ended up writing them separately. Terrible. This is not equal to. And that's a very common mistake. Kids are just trying to mix stuff together. But the rule is simply this. If they have the same base, we can combine the exponents. Let's look at another one. If I say 10 squared times 10 to the 5th power. Now, I want to be a dunce here. I'm going to write 1, 2, and then 1, 2, 3, 4, 5, right? So how many 10s do we have total? We have, well, here's the rule. Just add the exponents instead. 10 to the 7th power. When I'm multiplying powers, since they have the same base, we're just multiplying more on. Hop on board. Welcome to the party. And we're just going to add the exponents. Because we really are having 1, 2, 3, 4, 5, 6, 7 multiplying each other. So the general rule is, if I say a, sorry, let's use the different, if I say x, let's use a letter, that's fine, x to the a times x to the b, if they both have the same base, that means we add the exponent, x to the a plus b. What if it's a number? Okay, let's say it's a constant. Say c. C to the a times c to the b. This is c to the a plus b. And this is true no matter what you have as the base, as long as it's the same base. Right? We're multiplying it. That means we're just having more multiples of it. And what we do is we add the exponents. Now here is a weird Algebra 2 style question. If I say x plus 2 squared times x plus 2 cubed, do they have the same base? Take a look at the front exponent and the back exponent. Do they have the same base? Hopefully you may say, yeah, the base is x plus 2. It's a weird variable, but yes, they both have the same x plus 2 base. So if that's the case, we can add up the exponents. Now, do you always have to write 2 plus 3? No. You can leave it as, you can just say x plus 2 to the 5th power. You can save yourself some time and just jump from here to here. And everyone understands that. Mr. Ko, but don't you have to multiply x plus 2 and x plus 2? No. And the reason why is we had 2 of these and we had 3 of these. That's why we have 5 of these total now. Okay, so we're not going to multiply them again because the exponents count for how many we already have. Okay, the exponents already count for how many we already have. We don't have 2 plus 1 is 3. 3 plus 1 is, we don't have that. The way we read these is that this square here says I have 2 of these. This cube here, I have 3 of these. That means I have a total of 5 of these. Now, what if you end up with a problem that looks a little suspect? If I say 3 to the x times 3 to the 5th, are we multiplying powers with the same base? If we are multiplying powers with the same base, excellent. That means all we do is add the exponents. Now again, if you ever forget this, let's say you're taking the SAT and you're a little bit nervous about this, and you're like, man, can I really add x to it? Well, give yourself a easy problem. What if I wrote this with an actual number? Because remember, x is just a number, is standing in place of a number. And wouldn't this be 3 to the 2 plus 7? 2 plus 5 is 3 to the 7. So instead of writing a 2, you would write an x instead. And yes, this would totally work. Once you tell me what x is, it would just represent a simple number. Okay, let's see. What if we had a negative number? What if I said 2 to the 5th times 2 to the negative 3? And we'll talk about what negative numbers represent later. But what if we had a negative number? Well, it would still be adding. We would say 2 to the 5 minus 3. Well, we have 2 to the 2 power left. Okay. If I say 3 to the negative 4 times 3 to the negative 6, you owe me 4, you owe me 6, you owe me a lot. You say 3 to the negative 4 plus negative 6 is 3 to the negative 4 minus 6, if you want to rewrite it to make it look a little easier for your brain, 3 to the negative 10. You owe me 4, you owe me 6, you owe me a lot, you owe me 10. And we'll worry about negative exponents, how to express those in a different way next time. And the last part is a special rule. Here's our special rule. And that's 0 exponent. What if you have a 0 exponent? 3 to the 0, 5 to the 0, x to the 0. Whenever you have a 0 exponent, the answer is always automatically 1. 1. 1. Okay. X to the 0 power is 1 for x being a real number. And then 3 to the 0 is going to be 1. 5 to the 0 is 1. So if I write 3 to the 0 times 3 squared, well, you could jump and say, hey, that's just 1. And the answer is, what, times 3 squared is just 3 squared. Okay, we can just jump there. But I want to show you that this still works under our adding rule. 3 to the 0 plus 2, it's not 0, it's 3 squared, which is the same answer if I just switched it to 1. Let me do that again. Seems a little shady. 5 to 0 times 5 to the 4th power. We could say that's just 1, right? 1 times 5 to the 4th is just 5 to the 4th by definition. But we could also use our rule. 5 to the 0 plus 4, it's still 5 to the 4, which leads us to say that 5 to the 0 must equal to, whoops. So 5 to the 0 power must equal to 1. Okay. All right, so I'm going to give you guys a big mess of a problem. 3 squared times 4 cubed times 3 to the 0 times 4 to the 6. If I multiply all this stuff together, what is my answer? Do we have to go in order? Now, here is a rule that you guys talked about earlier. It's called the associative property. Of multiplication. Associative property of multiplication says I can associate with whoever I want in whatever order as long as we're all multiplying each other. That means 3 times 2 is the same as 2 times 3. The order does not matter and it still gives us the same answer in multiplication. Okay, I can associate with whoever I want to associate with if we're all multiplying. If we're all the same grade level, we can all hang out with the same kids. So what happens is we can always rewrite this as 3 squared times 3 to the 0 times 4 cubed times 4 to the 6. Just so that now we can see that they're next to each other. And since I'm multiplying exponents, we're just adding them. 3 squared plus 0 times 4 cubed plus the exponent 6, right? Because we said we can combine them by adding exponents. So the answer is 3 squared times 4 to the 9th. Can I combine the 3 and the 4? No, we are done. We can only combine them if they have the same base and they're multiplying. Okay, so if you see a big wild mess like this, we could rewrite it so that our similar terms are next to each other, and then we can combine our exponents through this rule of product of powers. Okay, that's it.